My guest today is Kurt Streutker.
Thanks, Tom. I just want to let you know that I have a fondness for this whole climate change issue, and I wanted to make a video that I call a layman's look at quote-unquote anthropogenic global warming climate change. So I had a friend of mine say, you don't use the word anthropogenic. No one knows what that means. So use the word man-made. So man-made global warming. And I want to say that on the onset that no one believes in climate change more than me. And I just want you, for the record, I want to completely affirm I believe and affirm climate change more than Al Gore and Bill Nye combined. They are literal climate change deniers compared to me. And I'll give you a bunch of reasons why. By the way, that app up, that meme up top there was my first meme I made on this climate change agenda. So it's kind of sentimental to me. It shows some of the nonsense we'll be talking about. So then, first of all, I want to mention that the science of climate is all about thermodynamics. There's the first, second, third laws of thermodynamics and so forth. Well, this one I made, this meme here, I made the composition of Earth's atmosphere. First of all, the major gases. The major gas, of course, nitrogen being at 78% of our atmosphere. We also have oxygen at 21% of our atmosphere. Now, those are the major gases. There's one more major gas measured in about 1% of our atmosphere. So we have 99% of our atmosphere is oxygen and nitrogen. And of course, nitrogen being number one, it's plant fertilizer. Oxygen is for us. Argon is kind of an inert gas, only 93% of that 1% left. Now, that little scant little bit right there, you can see that. This is all the trace gases. Trace gases, hydrogen and so forth. But the one that really is important for this planet and life itself is carbon dioxide. It's the molecule of life. This planet is actually quite short on it right currently these days at 0.038%. That's 400 parts per million. Now, if you notice that our contribution to that scant bit of carbon dioxide, which is 0.038%, is only 4% of that. So to make note of that, one great scientist once said, Roger Bacon said, mathematics is the gate and the key to science. So we can't handle this on emotion. We can't handle this on scandal. We have to look at it objectively, scientifically, because science is objectable, repeatable, observable, testable, and falsifiable. We have, I put on the side there some more things to look at, but I want to make another point here real quick. This is our friend Patrick Moore. He makes the point that carbon dioxide is not a pollutant. And he is a fellow who actually one of the founding members of Greenpeace. And he's come out to say some interesting things. Carbon dioxide is not a pollutant. And he is proclaiming this in his talks around the world, that it is a nutrient that is necessary for all living things. CO2 invigorates the biosphere, and the more of it, the better. And he goes around saying that, and he does a talk on that. And I will just move on to the next one here. Now, how much carbon dioxide is in the atmosphere? And does it really matter? I'm going to have to jump screens here. And this is what I want to say about what is a greenhouse gas. A greenhouse gas absorbs, holds, and emits heat. A greenhouse gas absorbs and moves heat from the sun into and through our atmosphere. What is the most abundant greenhouse gas? Well, by far, water vapor. Water vapor is the most efficient greenhouse gas, and it's about 95% of our planet's greenhouse gas. Only about 5% greenhouse gas is CO2 and a scant bit of CH4. CO2 being carbon dioxide, which is the molecule of life on this planet. CO2 is literally a non-player regarding climate and the weather. Now, man-made global warming scam. What is the main components of this scam? First of all, carbon dioxide is at dangerous levels due to human activity. As you can see to the right there, we only contribute 4% of that little itty bitty amount of gas. This is called thermodynamic nonsense. Lord Kelvin said, all science is numbers. If you just do the numbers and use common sense, you can see these atrocious ideas that they put forth on us. Methane is driving climate due to our diet of meat and dairy. How nonsensical is that? Notice that methane is 0.000, 3 zeros, 0.0001% of our atmosphere. This is beyond absurd to think that methane is driving climate, let alone carbon dioxide, which doesn't drive climate at all, which we'll be discussing in just a bit more. But methane is measured in parts per billion. So the scam breaks down to this. Carbon dioxide is the dangerous levels because of human activity, and methane is driving climate as well. And we have to alter our world. We have to take and attack our very civilization, because fuel and energy is very important for society today. That's what they're pushing. Now, one of the amazing things that I've seen out there is they're trying to capture and contain methane coming out of cows. As you can see there, one molecule of methane out of 500 molecules of our atmosphere. Methane is at 0.00017% of our atmosphere. When you look at this nonsense, you might think, I think it's safe to consume meat and dairy products. I don't think we should turn our whole economy upside down. Just over there on the right, you can see the nitrogen, of course, and oxygen, argon, and then that trace gas area down there. And then at the very bottom, you see methane. Now, to illustrate that a little bit better, I want to kind of throw this out to you here. So for carbon dioxide and all those things, I have these dollar bills here. You could put this on full screen. I have $2,500 here. These are single dollar bills, a pack of them. And you can see that we got a lot of them here. Now, this is $2,500. If this was all of our atmosphere, this $1 bill would equal the amount of carbon dioxide. Now, that seems kind of absurd, don't you think? But even more absurd is the fact that these 4 pennies would be our contribution to this dollar bill. 4 pennies, our contribution to this dollar bill, and that is driving climate. This is called thermodynamic absurdity. Now, to even drive that point home even better, I found this one the other day. This is $1 million in single dollar bills in a cube, 4 by 4 by 4. Cubed. Methane now is 2 parts per million. That's why they have to measure it in parts per billion. So out of that cube of $1 million bills, only 2, these $2 bills right here, these thin dollar bills, would equal the amount of methane if that whole cube was our atmosphere. Now, this is thermodynamic nonsense as well. It is an absurdity. And if anyone is out there who is a scientist, a physicist, and believes that methane is driving climate, they need to have their doctorate revoked and be taken out of tenure and thrown out of science altogether, because it is absurdity to the highest level. Now, anthropogenic global warming, or man-made global warming, as it were, is a hoax. Now, these are some pictures I got from the internet. Glacier National Park replaces signs saying glaciers gone by 2020, and they all say the same thing to that effect. These alarmists claim that CO2 is destroying our planet and its habitat. Global warming is melting the ice caps, and therefore oceans are rising and overtaking our cities. This is utter and complete nonsense. We are in a stable time. Now, I want to give a shout out to a friend of yours, Tom, and you could even let him know that I said that. Tony Heller, what a great guy. He's a historian of levels of, he's amazing. He goes back in the past and shows all kinds of things. What gets me is these climatista, these climate scientists are so-called. They said, stop trying to predict the climate future. And I'll tell you why. Because they can't even predict the climate past. if you know what I'm saying. Now, Tony Heller has put out on Real Climate Science tons of information regarding the climate past and showing that the ocean levels, for example, here are quite stable. And there's a picture of me at Bondi Beach near Sydney, Australia. Used to live there for about 4 years. And there's no significant ocean level change. Now, look behind me, there, those arrows back there. You can see that there's virtually no change whatsoever. You go back to 1989, 1909, and of course, in the 1800s, when the beach was first photographed, it hasn't changed a bit. So shout out to you, Tony, and I got another one for you. Fort Denison, Sydney Harbor. How is it that the fake news media is creating panic over sea levels rising when they're not? Isn't that interesting? They're creating panic. They're creating a serious crisis over nothing. Now, you see back in 1800s, they have a picture there with an old ship and the mast, and there's Fort Denison. Then here's a modern one in the 21st century just recently with even a palm tree on the thing there. Now, this is one of the things that I learned. And I was teaching back east, back in Cincinnati area, and I was teaching logic and ethics and different other things as well. And one of the amazing things I've found is that when you're arguing, when debating, false assumptions render false conclusions. And then I realized that the people I'm arguing with have false assumptions. So if I argue on the conclusion level or on the evidential level, they weren't getting it. It was like talking to a wall. What I discovered was I have to become a presuppositionalist. I have to deal with the presuppositions. False assumptions render false conclusions. And on the other side of it, true assumptions render true conclusions. So they deny the subjective reality that the fact that carbon dioxide is not a thermostat that controls our planet's climate. So like Rahm Emanuel said, you never let a serious crisis go to waste. And if you don't have a crisis, create one. Ocean levels are rising, and they're promoting it over and over and over again. But absurdity needs to be indoctrinated. You have to give them false assumptions. You have to run them, control them by fear and other things. So leaning back to the science of things, carbon dioxide, like I said, is a non-player regarding climate and the weather. CO2, for example, holds heat for only about 3 seconds. And it's only while the sun is on it. So CO2 holds heat only while the sun is on it. It doesn't hold heat unless the sun is there. Now, we can test this out, this hypothesis out, this idea, back in August of 2021 and recently back on April 8th this year. We had the solar eclipse that went over America twice now. Now, back in 2017, I had a friend of mine there in Colorado, went up there, and he said he had to go see the eclipse, and I didn't blame him. He's right there. So he was up there. He said it was in T-shirt weather, just like here. I got my T-shirt on from Mount St. Helens. He was in T-shirt weather, and he said it was 80 degrees. It was beautiful weather. And as soon as the solar eclipse hit, he said it dropped the temperature down to 65 degrees. It went down 15 degrees almost instantaneously. Within 10 seconds, he said to his wife, "We need to get some jackets on. It's cool." Well, there's a reason for that, because carbon dioxide doesn't hold heat for more than a few seconds. Now, bear in mind that a friend of mine, also, I had a bunch of friends on this last one I kept in contact with on this one back in 2024, April 8th. A friend of mine in Texas was saying that he's an astronomer, actually. He went there and wanted to see it. He's seen a couple of them now. But he was there parked in Texas, and he said that he started feeling it getting colder about half. The sun was covered by half the moon, and he started feeling it then, which was kind of interesting. He didn't get to total eclipse before he felt the cold. He started feeling the drop in temperature about halfway through. And then he saw the extreme cold, or the cooling quicker, as he was going into total coverage of the eclipse. And lastly, I want to make a note that CO2 is 1.5 times heavier and therefore tends to fall. I do an experiment back in the day, and I wasn't going to do it here, but you take a jar of carbon dioxide and you pour it over a candle and it drops it out because it tends to fall. Carbon dioxide is heavier, 1.5 times heavier than air, and therefore tends to fall. And God in his infinite wisdom, of course, did that because this is where the plants are. Imagine if carbon dioxide was light, like helium. It would rise up and the plants would never get it. It's got to stay low. That's why we have a tree line, by the way, because trees survive they have to have so much carbon dioxide to survive. And by the way, we're actually CO2 poor right now. We've had more in the past. During the, if you go look, and I'll mention this a little bit later, but the Volcanic ice core samples in Antarctica mentions and shows, the data shows, not the all these different interpretations, but the data actually shows that there has been fluctuations of carbon dioxide. And it turns out that the oceans degas when they warm during the El Nino event. They'll degas more carbon dioxide, releasing more carbon dioxide in the atmosphere, creating a greener planet, and then actually helping the planet with life. During colder periods, during ice ages, you get less carbon dioxide. So it's the complete opposite, like our friend out there in Australia, Ian Plimer, was saying. He says it's a complete inverse. You don't get carbon dioxide, then heat follows. You get heat, and then more carbon dioxide as a result because the oceans degas. So again, carbon dioxide is necessary for our life on our planet. It is literally plant food. The more carbon dioxide, the better, as many have said actually throughout the years here. And this information needs to get out to people out there, the layman people. Like I say, I'm a laymanizer and I'm a popularizer of this particular information. Okay. Now, to illustrate the hot and the cold, the arid desert will help us do that. The Sahara Desert in North Africa, temperatures in the Sahara Desert can drop on average of 75 degrees Fahrenheit overnight. Temperatures in the Sahara Desert plummet once the sun sets, an average of the high of 100 degrees Fahrenheit during the day and an average low of 25 degrees Fahrenheit at night. Now, why is there such a dramatic temperature shift happening in arid deserts? And the key word is arid. That's because deserts have very little water vapor. Remember, water vapor is the #1 greenhouse gas. It holds heat much longer and much better than carbon dioxide, which only holds it during the day for a few seconds while the sun is on it. Now notice, tropical regions such as Hawaii, Fiji, Philippines have abundance of water vapor, which holds the heat and keeps a mild climate and a more delightful climate for people to spend time outside. Now, for example, when I was living in Hawaii, I would go out under the palm trees and have a hammock out. And I would sleep out on the hammock, looking up at the stars when it was a beautiful night. And I would not even have to use a cover. I just had a pillow and the palm trees and the stars. And it was so amazing because why? The water vapor held the heat like a blanket. And that's why the tropical regions are warm at night. But arid deserts with no water vapor get very cold at night because carbon dioxide does not hold heat at all during the nighttime when the sun is not on it. So these things, these factoids, bring a lot of question to our climatistas, these climate alarmists' assumptions, and they're postulating this and pushing this into our kids' minds that the earth is collapsing and the environment is collapsing because of our use of fossil fuels, which emit carbon dioxide, which of course actually is a good thing for the planet. All right. Now, our friend Happer and Lindzen talk a little bit about this thing called clouds. Actually, Lindzen talks a lot about the clouds. What effect do clouds have on the climate? Well, clouds cover about 70% of our planet at any given time, which is interesting because our oceans cover about 70% of our planet currently. So all clouds combined have a net cooling effect on the earth. When I was living back east, I was working outside and different other places for that matter. And I was always looking forward to clouds coming over to cool it down a little bit because it was the direct sun. It was hot, even in Hawaii for that matter. During the summer months, it gets very hot there, and it's nice to have a cloud cover a little bit because it blocks some of that sun direct heat. Now, number 3, clouds not only affect temperature, they also are affected by the temperature. So not only do they affect the temperature itself, but they are affected by the temperature because clouds do a number of things. They block the sun. As a matter of fact, as you can see in that picture there, this is flying over from North America to Hawaii. And during an El Nino event, you see lots of clouds. You see clouds almost all the way across to Hawaii. It's amazing how much cloud cover you see over the oceans. Well, that cloud cover is because the warm oceans create the water vapor, which then droplets form and, of course, clouds form and so forth. And then you have clouds going over the continents and, of course, causing rain and so forth and precipitation. Now, these sort of things are necessary for life. And El Nino events we call it the ENSO effect, the ENSO warming. It's called El Nino Southern Oscillation. And oceans and clouds play a leading role in our planet's climate. The warm oceans release the water, it becomes clouds, and those clouds move over to the land and so forth, but they also block the sun. Now, over the oceans, they block the sun. So what happens when the sun's not hitting the oceans? They start to cool. So we have this oscillation effect, a heating and cooling, and it's self-regulating. That's what's so amazing about it. And clouds, like I say, not only affect the temperature, they are affected by the temperature. And of course, the oceans cool and they heat based on these sort of things as well. So this climate feedback from warming. The oceans block the sun, and they also keep the warmth in at night. They have a cloud cover that keeps it warmer at night. So it's to make a little blanket. They are amazing things that we have here. But like I said, they cause a net cooling on the Earth. Now, slowly getting to my main point, climate change and history. And a lot of the speakers that you've had over here, Tom, have talked a lot about the ice ages and so forth, the Roman warming period, the medieval warming period, and so forth. Now, the Great Ice Age is what I'm going to be focusing on here shortly. But just to give you a couple notes about volcanism. When there's a volcanic dust that's in the atmosphere, aerosols and so forth, that blocks the sun, therefore we have reflection back into space. These are the things that cool the planet enough to have an ice age. To have an ice age, you have to be freezing or year-round to have an ice age, and it has to be freezing down lower on the altitude or latitudes. Once it gets down to lower latitudes, we had ice clear down into beyond the Great Lakes, down toward Indiana, Kentucky, and so forth. Now, what would cause ice to form sheets that are up to a mile deep, say in Chicagoland, Detroitland? And we also had ice here in Yosemite Valley in California, up to almost 2 miles deep of ice. That's a lot of ice. That's an amazing ice age. That's the Great Ice Age. We've had 2 smaller ice ages called the mini ice ages. And we just came out of the Little Ice Age, recently out of 1850. So if you want to look up more on that for your students out there, a fellow named Michael Ord is an amazing scientist that has done a lot of work on the ice ages and has correlated these things and put it out there for us in a lot of videos, a lot of pictures and so forth. So I just recommend look up Michael Ord on that one. Shout out to him. Now, showing how volcanism affects the climate. In 1850, eruption of Mount Tambora produced the quote-unquote year without a summer. Now, there it is near the equator, which is critical. When you have a volcano blowing up lower down on the system or up above, it stays in the northern or southern hemisphere, but it's on the equator. It kind of spreads out throughout every area, north and south. So plumes from Mount Tambora, the eruption, reached about 27 miles. And this an eruption expelled about 24 cubic miles of ash, pumice, and aerosols into the atmosphere, along with about 60,000 kilotons of sulfur dioxide. Important word there. I'll come back to that later. 60,000 kilotons of sulfur dioxide. Extra material in the atmosphere, which meant less sunlight, reached the Earth. And in 1816, there was a year without a summer. And this not only lasted just 1 year, but it lasted a number of years out, but it brought in all kinds of problems. When you block the sun, Bill Gates, you cause problems. You don't want to do that. We had famines. We had pestilence. We had all kinds of things happening because there was no growing season. People literally were starving because of lack of sun. So Mount Tambora had dropped, by the way, an average of 5.4 degrees Fahrenheit global average in 1816. That's a significant amount of volcanism. Now, here's one of my favorite volcanoes there off to the right, Santorini. And it shows an overhead picture of it. It blew up. You can see right there the caldera is that open gap. And there's a little ships you can see inside there. This dinky little thing's little white thing there. And in the middle there, you see a lava dome. Important, I want to make that point now. Lava dome. And that thing erupted in 1620 BC and literally laid waste to the island itself, burying a city there on the southern side there, like Pompeii. And cause a massive things, including, well, we won't get into all the details now because that's a rabbit trail. But let me go over to Krakatoa or Krakatau. You see that little island there called Krakatoa or Krakatau? That was a big island at one time. And then you have Anak Krakatau, which is the lava dome that's took place. So we've had the first major eruption. It was in 535 AD. And that was a massive blow up. It blew up the island just like you see there at Santorini. And then we had another volcanic eruption that blew up again in 1883, August 26, 1883, where that island blew up again. And now we have a lava dome that's kind of Anak Krakatau. Anak means son of. So that's the son of Krakatau. He's a little island. Now you see him below there. He's blown up a number of times. These events take place and cause drastic action in our atmosphere. And remember that about blocking the sun. Okay. And I can get into more detail on the different things. Just like Tambora, this also had climatic changes because Krakatau is right there in the middle of the Earth there near the equator. All right, next one. I want to show this one here. This is where we are. This is where I kind of did a lot of my work at Mount St. Helens, where I'm wearing the T-shirt here. And of course, here near me in Sonoma County, or Napa County, actually, I live. It's right behind me, literally, in Calistoga. Is a city there called Calistoga, and right behind it is Mount St. Helena, not Helens, Helena. So the Cascade Mountain Ranges there is particularly put there by the Juan de Fuca plate. And this is a subduction plate going underneath the continent. Now, let me make a couple points here real quick, and I'll get back to that. The continental plate is roughly about 25 miles thick, floating on the mantle. And the oceanic plates are very thin. They're only about 4 to 5 miles, about 4 miles, I think, on average. They're pretty thin compared to the 25 miles. So the Juan de Fuca is subducting under it. So his force is pushing there and causing these volcanoes to go. Now you can see over the timeline for 4,000 years that we've had quite a few volcanic eruptions. Baker, of course, Rainier, St. Helens, Adams and Hood. And of course, one of my favorites is Shasta. Shasta's gone off a number of times. Now you have a picture there of Mount Lassen. This is actually from Red Bluff, California. May 22, 1915, Mount Lassen blew up, and you can see a picture of it there. These events put tons of atmospheric ash and dust into the atmosphere. And these sort of things cause climate change. See how much I believe in climate change? More than Al Gore and Bill Nye combined. They're dinosaurs compared to me. But there's a nice picture of the Cascade Mountain Ranges. But I want you to take note of Mount St. Helens. It's been pretty active over the years. It's a beautiful stratovolcano. And we'll talk a bit about that in just the next slide or two. But there's Adams and Mount St. Helens there, right next to each other. And you can see that they've been rather active. Now, St. Helens has been chiefly active in this, but they kicked out a lot of ash in the atmosphere. And that ash prevailing winds always tend to go east, covering the United States. This is why we would have an ice age. When you have a lot of volcanism blanketing the ash and covering the atmosphere with ash, blocking the sun. Okay, key point. We'll get to that in a moment too. I just want to make another shout out to Mount St. Helens. Here we go. Here you go. Here's Helens. There it goes. There it goes. Mount St. Helena, first of all. Mount St. Helena, this is the one right behind me there. This is a picture of what it used to look like before it blew its top about 4,000 or about probably 1,300, or no, I'd say about 3,500 years ago, roughly. We don't have exact date because no one saw it to record it for us. But anyway, Mount Shasta there below, that's coming up north. Mount Shasta, driving north on I-5, and this is from the south, looking south down at it. Two different angles there. Notice that's a nice, beautiful stratovolcano, just like Mount St. Helena was. Mount St. Helena blew up, and they created what they call the petrified forest, which is up there in Napa as well, where all these trees were knocked over and buried with volcanic ash, and of course, permineralization takes place. And permineralization is how petrification takes place, where the water-laden ash goes through the ash and gathers up the minerals and replaces one molecule at a time, which is permineralization. So I just want to make that point there, and you can see how these volcanoes did a lot of work. This is here in Napa County area. Now, Mount St. Helens, this is a shout out right there. I want to make a special shout out right now to a good friend of mine, Steve Austin, who also is one of the main guys who did a lot of research at Mount St. Helens. I want to thank him. And also Keith Ronholm for these photographs. He was a photographer up there. And he took that blast shot right there, May 18th, 1980 at 8:32 in the morning when it blew. He took those pictures, a series of pictures. Now, that was Mount St. Helens there on May 18th, 1980, just before, and that was right after there. You can see that this stratovolcano had a massive explosion that took place over a course of many, many months and actually over years, because it kept on exploding and doing its thing even into 1982, where you see a lava dome there is forming there in the caldera of that volcano there. You can see there off in the center in the left there, to the right, that these trees were blasted. I won't get into all the details about what caused those trees to fall, but those are not little trees. Those are old growth redwoods. Old growth trees, I should say, that were knocked over and like twigs. And you can see the blast zone there. And again, with Keith Ronholm's pictures and, of course, Steve Austin's research, I'd encourage any of you folks to get out there and look up Dr. Steve Austin and St. Helens and see what he has to say about that. A lot of geologic stuff took place. Now, Mount St. Helens. Now, a cloud of ash kept going across the United States, and this is all documented recently in the 80s. It went over to Maine in less than 3 days. It was pitch black dark. Street lights were on underneath the ash cloud. Because why? It was dark because the sun was completely blocked, and it was much colder because the sun was blocked. Now, this is what I come to my hypothesis here. Shortly, I want to talk about this, but I want to make a couple points here. This is on Tonga. This is the eruption recently back in January 15th in 2022. Interesting time, by the way. We had a lot of rain after that. And I'll tell you why. Tonga eruption blasted an unprecedented amount of water and ash into the stratosphere. Why water? Well, there was in the earth we have water, and of course it's in the oceans too, but it kicked out tremendous amounts of water. It was a massive explosion. As a matter of fact, it sent a pressure wave that they felt and saw in Hawaii. They saw these waves go across, these pressure waves, these clouds are being pulsated through, and they found even into Hawaii area. Pressure waves circled the globe several times. Temperature rippled across the Pacific. Now, this is like a time thing here. They saw those are satellite pictures, obviously. But this particular event put an excess amount of water injected into the atmosphere from this volcano. And in the stratosphere, it's going to be there for a number of years, they said. And it obviously affected climate, but on a different way. Now, how did it affect the climate? This eruption did affect the climate. The Tongan volcano emitted only, I'm going to say only here, 112 kilotons of sulfur dioxide. Compare that to the other volcanoes. Tambora, like say, 60,000 kilotons. Pinatubo, there in 91 in Philippines, 20,000 kilotons. And of course, Ichichon in 1982, had about 70 or 7,500 kilotons of sulfur dioxide, whereas the Tongan one only had 112 kilotons of sulfur dioxide. Relatively small, but that was offset by the amount of water vapor that was created and sent up into the atmosphere, which then caused a lot of rains. It was almost like a perfect storm. We had these, what they call these cyclone bombs that were coming across the California, get lots of rain. I remember our house was flooded and a lot of houses got flooded. I had to do some cleanup, but there was so much water, our house got a little flooded down there in the basement and so forth. But my point is this, is that because there was so much water in the atmosphere, it fell down on us and gave us lots of precipitation for a number of years, actually. But it didn't affect the climate as much because sulfur dioxide was not as much as it would be on other things. So sulfur dioxide is a clear and present danger when it comes down to creating an ice age. Okay. Now, causes of what I call the post-flood ice age. Sun rays are reflected and therefore cooler summers. These aerosols and ash and water vapor get into the atmosphere and block the sun. And to have an ice age, one must have cold continents and warm oceans. Warm oceans to get the water out and cold continents to trap it there. To have the great ice age, you need a major heated ocean to kick the water out continuously. Because if you have a world that's just cool, it won't kick out the water. You need to have water kicked out of the ocean throughout and then caught up in the atmosphere and carried over to land. And then you can then say, okay, now we have an ice age because now you trap the ice there and the water there in the form of ice. So volcanism and volcanic eruptions are the primary causes of ice ages. To have a great ice age, there must be warm oceans and cold continents. Now, currently, there's about 1,500 active volcanoes in the world and about 20 to 30 eruptions per year, roughly. Now, bear in mind, there's only about 6 or so supervolcanoes, and supervolcano would be classified as a V8 or 8VEI. It's Volcanic Eruption Index, Explosivity Index. It's a V8, I call it. And you got, of course, Yellowstone. When that thing goes, we're going to have a nuclear winter and lose half of America. That's just how it's going to be. We have other ones, of course, but I consider Hawaii a super volcano, and it's in the middle of the Pacific Ocean. And I think that's really the key to our understanding of the great ice age. Now, I call geology the forensic study of the past. We're looking at a crime scene here. The crime scene being, look at that nice, beautiful volcano there with the ice caps, but it goes down deep. It goes down way down into the ocean. As a matter of fact, Hawaii, if you're looking at Hawaii, the big island, it's a shield volcano. It goes way, way down into the ocean, but most of it is underwater. And if you look at it from the aerial view there, we have Kilauea, of course, which is the active part. We have Mauna Kea, Mauna Loa. Mauna Loa just erupted recently, and you can see some of that there. These are satellite pictures, obviously. But when you look at Mount Everest compared to Hawaii, what do we see? Mount Everest is considerably taller. Mount Everest is only 29,028 feet. When I say only, it's the tallest mountain from sea level. But when you see Hawaii from the bottom of the sea where it started, it's 33,500 feet. That means it's about 4,472 feet taller than Mount Everest. 4,472 feet taller. That's considerably taller than Mount Everest. But then it started underwater. Now think about this. This is the forensic state of the past. Now, remember, to get a ice age of the great ice age level, we have a mile deep of ice covering America, Detroit land, Chicago land, the Great Lakes, all that area, a mile deep of ice, moraines everywhere, leaving its evidence there, its crime scene of the ice age. You have to have a lot of water leaving the oceans. Now, my hypothesis, which I can't prove that yet, but I'm working on it and have been working on it. I've worked with a number of people with the Sandia National Laboratory, et cetera, that have hypothesized with me on this, that a meteor strike could have caused that hot spot, which would have a devastating effect on the continents, sending tsunamis across the ocean, massive tsunamis. So see a meteor or a series of meteor strikes hitting in the Hawaiian Islands could cause those hot spots that we have there. That hot spot, remember, it's only 4 miles deep, roughly, to get to mantle, to get to the magma. So you need to have a big enough meteor to hit the ocean, go down and penetrate 4 miles, and then cause a bleeder. That bleeder then would send, of course, mass tsunamis across the oceans, or across the Pacific Ocean into the mainland areas. And also, that would necessitate magma hitting water. Magma hitting water is very hot and creates a lot of steam. You need warm oceans. You need a lot of steam. So if I have this event, meteor take place, now we have meteor strikes on the Earth. Sometimes they piddle out and they get fried by the atmosphere. Sometimes they hit and they thud and they leave craters. Now, I didn't get into all those slides here, but you can go and research where the meteor strikes have hit in America, for example, and there are other places. We know that meteors have struck this planet and have caused tremendous damage. Now, if you hit the continent, it has to go into 25 miles. That's going to be a lot harder to get down. But when you hit 4 miles and water, and it goes into the water and creates a bleeder, now we have a possibility of having a great ice age, because for every action, there's an equal and opposite reaction. Now, this reaction would be what? The Juan de Fuca plate, the plates hitting underneath North America, causing massive amounts of volcanism, causing the volcanism to blanket across the ash, across the fruited plain and so forth, causing the sun to be blocked. We have massive amounts of steam coming up. So we have ocean steam and blocking the sun. We can have 2 miles deep of ice in Yosemite Valley. We'll look at that in a moment. But just bear in mind that the Ice Age was an incredibly difficult time to live. We look at the world today through very small glasses. You have to open up a little bit. When I was doing my studies in geology, I tried to open my eyes a bit more to see the big picture. And like Ian Plimer and so forth in Australia, he looks at some things and he says, look, when you look at the global warming theory or hypothesis, it falls on its face every time geologically. That's why I like Tony Heller so much, who looks back in the past. And like I said, these climate scientists trying to predict the future, they can't even predict the past. It's absurd to think that we have this sort of thing happening because of carbon dioxide, which is not even a player. Methane, it doesn't have an ounce of effect on the climate. But yet they're pushing and pushing and pushing and teaching our kids to think that this is a existential threat. We have politicians saying if we don't get this thing under control in 10, 12 years, we won't have an existence on this planet. That's absurd. So anyway, the Great Ice Age. And I think the key is Hawaii. And like I say, this is my hypothesis. This is what I did my dissertation on. This is where I've been doing some work in Hawaii when I was there. And I love Hawaii. It takes only about an hour and a half to drive across the island, but it takes me 3 hours. And why is that? Because I stop everywhere and look at the rocks, get out and get my little hammer and pound on things and break things open. It's just all lava, though. It's not like sedimentary rock, which is more interesting. But Hawaii is the key, I believe, to the Ice Age, the Great Ice Age, and the amount of water that came into the atmosphere through Hawaii when it was forming. Because when you see these little volcanoes like Kilauea going off and hitting the ocean, you see massive plumes of steam. Well, imagine that whole island being formed underwater for years and years and years, causing that steam to rise and go over the continent of North America and causing ice age. Now we have ice age that went all the way clear into Siberia. That's where we get the mastodons frozen in their tracks and so forth. So much more to cover. But I just want to give you a primer on this. I want to give you a layman's look, a flyover review of the ice age from that perspective. Now, Yosemite Valley, one of my favorite places to go. You can see that little train going up there. It's like little ants crawling up a hill there. There's actually little cables, and they kind of walk up the stairs. Well, I went on that years ago in the 80s, the first time up to the top. They were just laying there. You climb like Batman. Then they put them up on little holds, and you can kind of walk upstairs. So people can do a little easier. I can get into a lot of details on that, but it's a beautiful place to be. Great vistas, amazing rocks, many stories, many good times there in Yosemite Valley. But I want to say this, Yosemite Valley is the monument to the Great Ice Age, where you had over, I mean, we're not even talking about, we're talking 2 miles of ice covering that area and carving that great looking half dome that we call it. And through those areas, El Capitan, etc. The Ice Age, what would necessitate 2 miles of ice? This is southeast of me right here in Calistoga area, in near Santa Rosa and Napa Valley area. This is southeast of me, about 200 miles, 250 miles roughly, to get there. How did that much ice get there? My explanation was the Great Ice Age and Hawaii being the key, being that supervolcano that formed underwater, creating all that pillow lava and ash in the atmosphere, but mostly the water vapor that goes into the atmosphere goes over the top, and then that triggered the ash in the atmosphere from all the other volcanoes going off at the same time. Now, one of my favorite places to go, I travel the world, is a place called Meteora, and that's where we get a word meteor, which means high and lofty. Now, there's about 24 monasteries on top of these cliffs, or these big monoliths. Well, these monoliths aren't like Yosemite. Yosemite is granite, one big, huge pile of rock, one big rock. These are conglomerates. Now, look at the pictures below. Interestingly enough, this is hard cement. I couldn't even break it. It was so hard. It was like you really had to work at it. So I went there and did a little work as a tourist and instantly put on my geological hat and started doing some geological studies while I was there, because I wasn't expecting to have so much fun in geology. As you can see, I have tons of pictures. And these close-up pictures to me were the most amazing. You say, look at those beautiful vistas. I say, but look at that rock. Those rocks are brought in by water. Now, it's just like the Shinnerup conglomerate there in the four corners, and it covers many states, thousands of miles. And it's about, I think it's about 200 feet thick, roughly. A Shinnerup conglomerate, which is a bunch of rounded rocks, usually, because they travel underwater and they tumble and, of course, get rounded. This is similar to that. So it made me think, wow, look at this. And it was cemented, of course, because to have cement, you need water. So it was a massive dump of water-laden sediment moving across at a pretty good, fast rate for a while, because most of those rocks we'll see here in a moment are granite. And those rocks were laid there and deposited. Now, interestingly enough, after they were deposited, we had the Great Ice Age, and that's what carved these canyons. These canyons were carved by ice, just like fjords in Norway and, of course, Sweden area, and other places like in Yosemite. So when you look at this place called Meteora, I believe that is also a monument to the Great Ice Age there, right there in Greece. It's about a 4-hour drive north of Athens. Takes a while to get there, but it's well worth it. One more picture of Meteora here. There it is. Look at that granite rock there, cemented in there. And look at these granite rocks there. This is up top there at a monastery, actually. I was up to, there was actually, like I say, 24 monasteries up at the top of those little mountains. And there's 12 of them that I was able to see, and I got into about 6 of them, which is really kind of neat. So, but nonetheless, though, these big boulders, little rocks, big rocks, all together just kind of rolling and deposited. There was a major hydraulic event that dropped in and deposited these rocks, and then a subsequent ice age that followed. Now, just shortly closing up here, climate is a dynamic and highly complex thing. It is not boiled down to a couple molecules of carbon dioxide changing the climate and creating disaster because of our fossil fuel burning. Absurd. The planet must have liquid water, steam, i.e. water vapor, and solid ice simultaneously to be able to sustain a proper balance in this world. We need to have water, steam, and ice to create the cold, steam to create the warm and moving it, and warm water, okay? Because we got to have the moving of the water, and we have to have moving of the air, and that's what causes it. We have this thing called we're in this what they call the inhabitable zone, or I call it the anthropic zone, or they have different names for it, where life can exist. A little too close to the sun, and you heat up, you have too much steam, no ice. A little too far from the sun, you get too much ice, no steam, and you have problems. So we have this just right area. Now, we're also in an elliptical area, so we're a little closer, a little further, depending on where we are in the elliptic. Actually, during our winter, we're a little closer to the sun. But the southern hemisphere, being mostly water, doesn't have a big problem. And during our winter time, we probably need that to be a little closer just to make our winters not so difficult. But they're difficult enough because we do get a lot of ice. The sun and water vapor are the primary drivers of climate. And of course, the distances and so forth and so on. Now we have solar flares, sunspots, we have a tilt. All these factor in to climate. And by the way, our globe, as you can see over here, if that globe was that, our atmosphere would be a couple pages of paper thick, just wrapping around it, protecting us. But that particular is to try to isolate these models, as Lindsay talks about, where they ignore clouds and ignore different things. They never get it right, not once. It's like trying to nail Jell-O to a wall. It just doesn't hang in that long. It's ridiculous. The sun is the primary, and the water vapor primary drivers of climate. Carbon dioxide is not. Carbon dioxide is necessary for all living things. It makes the planet livable for human life and plant life. Of course, we need that for photosynthesis. And again, our tilt of our planet currently is 23.4 degrees. And the Milankovitch cycles, we go through cycles. And our last speaker on your broadcast, Tom, was talking about these cycles that we go through. And they're pretty regular. We go through these cycles, and it's based on a number of factors, like I say, solar spots, solar flares, and atmospheric regulation through the clouds, and of course, volcanism, which also does things. Lots of changes, but carbon dioxide has nothing to do with it. So I want to make a point here. Last time I talked with you, Tom, we talked about the Lost Squadron. This is my slide that I wanted to show you. And I thank you for putting that slide up last time. That was great. But World War II, P-38 fighter flight was found in Greenland ice. Now think about this for a moment. This is back in 1942. 2 B-17 bombers and 6 P-38 fighters were en route to England from the United States. They flew over Greenland. They had to do a crash landing. Next, the P-38 was rediscovered back in August of 1992. It was dubbed Glacier Girl, of course. And they restored it to flight worthiness quickly. And they basically dug a hole down there. They went down 75 meters, which is 250 feet. That's where it was, buried in the ice. Now, this is during a warming period, folks, and we still get that much ice. Imagine during an ice time, during a time when there's a glaciation, when it was a another ice age, a little ice age, we would pile up so much more ice, so much quicker. But this is during a warming period. Now, one thing about a warming period, we have water vapor kicking out of the ocean still, you see? So this is where we get this buildup of ice, and it builds up quite quickly. Now, it was found in let's say 260 feet of ice. It accumulated just that much in 50 years. That's pretty quick. Now, I want to make that point because we have these assumptions, false conclusions that these things take thousands and thousands and thousands of years. No, they happen quite quickly. We have mastodons frozen in their tracks during the Great Ice Age, where they actually found thousands of them. Matter of fact, there's an industry of harvesting tusks of these mastodons, and they had thousands and thousands of tusks that they were getting from these mastodons that were, of course, trapped in ice. They're up in Siberia area. Well, I want to make a closing comment here or two. Up here on the top left there, we have the climatistas. These are the multimillionaires, the millionaires, and even the billionaires who are pushing climate change. Now, even Greta Thunberg is a multimillionaire now. Thankfully that she is out there promoting climate change, and therefore she is paid heavily and much, and her family has now become quite rich because of this. But the one guy who's a traitor, his name is Michael Mann. Of course, he gave us that great hockey stick, that little hockey stick that uses proxy data and ignores the data that it contradicted his whole hypothesis of the hockey stick. So he says, basically, there was stasis and no change at all. And all of a sudden, boom, we have carbon dioxide. And of course, we have global warming, all corresponding with the heat. Absurd nonsense. He's been exposed as a fraud, and I just encourage you people to look up him and see some of the stuff that he has stated. And the refutations are endless, because what happened is he was exposed by information, because this whole idea of climate change, man-made global warming, etc., survives because of censorship. And of course, these multimillionaires control the media and control the flow of information. And for example, these fellows below there and these ladies are also censored. They say there's no climate emergency. Hey, wait a minute, I thought there's a climate crisis. No, there's no climate emergency, saying Nobel Prize winners. Of course, Richard Lindzen, MIT. You've interviewed these folks, Susan Crockford, etc. You've talked to Judith Curry a number of times. You talked to Ian Plimer and many others. These folks here are real scientists who have lost everything because they dared speak against the fake news narrative, this whole idea that man-made global warming is real. Now, the Biden administration has also capitalized on this by spending $300 billion to fight climate change in 2022. Totally absurd. Now, below there, I have a little note there. There is the late great John Coleman, who says that he's not a climate denier. He's a climate change skeptic. And he gets on there with CNN and basically browbeats them and saying there is no climate change, no global warming, no significant global warming caused by fossil fuels. It is absurd. And he makes that point. So I encourage your folks to look that one up. Brian Stelter talking to John Coleman. And I like to say, follow the money, because a lot of that $300 billion was there to fight climate change was going into people's pocket. It's just like throwing money down to the drain in any other areas. But these climate scientists below there, like Richard Lindzen, Plimer, Crockford, Curry was actually at Georgia Tech. She was the head of her department, but she is no longer. There was another one, Crockford. She was the world authority on polar bears up in Canada. Guess what? She got sacked. And of course, you've interviewed William Happer. He's another great one there. I encourage your folks to listen to your podcast and get some of these. I have a couple more slides here. I'll just wrap this up real quick there, Tom. As a recap, the summary of these key points: climate change is a real phenomenon. No one believes in climate change more than me. Carbon dioxide is crucial and necessary for all living things. It's not a pollutant. It invigorates the biosphere, increases food production. Notice the greenhouses that we have. They pump in carbon dioxide, giving greenhouses a chance to grow faster, get a bigger crop, and use less water. Carbon dioxide is trace and currently makes up only about 400 parts per million of our atmosphere. Human contribution is only about 4%, which is 16 parts per million. Water vapor is the main greenhouse gas. 95% of the Earth's greenhouse gas is water vapor. Carbon dioxide makes up only 5% of the Earth's greenhouse gas. To think that we contribute only 4% of that is absurd. Carbon dioxide holds heat for only a few seconds, only while the sun is on it. Look at the Sahara Desert, etc., the solar eclipse. Carbon dioxide is not only Earth's thermostat, is not the Earth's thermostat. It is not the control knob, as you say, of climate. Carbon dioxide is 1.5 times heavier than the rest of the Earth's atmosphere. Note the tree lines and plant life and so forth. All clouds combined cause a net cooling effect on the Earth. Clouds cover only about 70% of our planet. Climate is dynamic and highly complex. Climate change scam uses fear and ignorance to control and move money, control us, move money, and gain power. Man-made global warming hoax survives because of censorship. They censor real empirical science. Man-made climate change scam is exposed by real science, like thermodynamics. The main fallacies are used by these climatistas, these climate alarmists, are ad hominem. They will always attack the arguer, not the argument. They will say all manner of things. They will appeal to emotion, appeal to authority. They'll use red herrings. They will use slippery slope. They will even argumentum ad populum, etc. But the one they use the most is ad hominem because they like to attack the arguer rather than argument. Real quick homework, you can maybe make a screenshot of this, but you can look up oceanic degassing, the volcanic events and so forth. The Milakovich, I like the reference to John Coleman, the Weather Channel founder. You can look up Greenpeace founder Patrick Moore. Polar bear expert got sacked. Of course, Susan Crawford, I mentioned her, and also Peter Ridd, who you interviewed from Australia. And these other folks that you've interviewed, I'd encourage your listeners to take these videos and to share them with their friends. There's your website there. And if you want to do more work on the ice ages, you can always look up Michael Ord and, of course, Steve Austin. Shout out to them for their work at St. Helens and so forth. But a big shout out to you, Tom, and the work you're doing there with the exposing the climate crisis / scam. All right. Thank you so much.
Okay, thank you very much. I don't have time for a Q&A today, but is there any chance that you could answer questions in the YouTube comment section or no?
Absolutely. I will be there to answer as many as you give me.
Okay, let's do that. All right. Thank you very much.
Thank you.
We'll talk to you next time. Kurt Streutker.
Take care.
Bye.